In this tutorial, we will find the inverse function and the domain of the inverse function. The daily quantity of rice Q measured in tons that is supplied to the market is thought to be related to the selling price P by the formula P equals 0.2 Q plus 400 all under the square root, where the domain is all Q greater than or equal to 0. Find the inverse function giving Q in terms of P and state the appropriate domain. The supply function that we're given has P in terms of Q. In other words, P is by itself. To find the inverse function, we need to get Q by itself. So how do we solve for Q? We see that 0.2 Q plus 400 is hiding under a square root. So in order to get the Q, we need to eliminate the square root. We do this by squaring both sides of the equation. $400 is being added to the term containing the Q. To get rid of it, we subtract 400 from both sides. Since Q is being multiplied by 0.2, we will divide both sides of the equation by 0.2. On the left side, this amounts to dividing each term by 0.2. The coefficients are fractions that we can simplify. 1 divided by 0.2 is equal to 5, and 400 divided by 0.2 equals 2000. Now we have the inverse function since Q is in terms of P. We need to determine the appropriate domain of the inverse function. Let's think about what our inverse function means. If we substitute a price value in for P and solve, we will obtain the quantity of rice we can get at that price. Since P represents a price, we know already that P must be greater than or equal to 0, since we can't charge a negative price for something. Also, when we choose a price, we cannot get a negative quantity in return. So Q must be greater than or equal to 0. In other words, we want a price such that the quantity is greater than or equal to 0. So we need to solve the following function for P. We'll add 2000 to both sides. Now we'll divide by 5 to isolate P squared. Now we need to square root both sides since P is being squared. But remember, we don't want a negative price. So P greater than or equal to 20 is the domain of the inverse function. And this completes the exercise.